Welcome to section 9.5a. We're going to use the quadratic formula. This is another method to solve quadratic equations. Our other methods, we've done all of these at this point. We factored and set each factor equal to 0. We graphed and looked for the x-intercepts. We completed the square in section 9.4 and 9.4a and b. So now we're going to do quadratic formula. First thing that you want to do when you're doing quadratic formula is make sure that your equation is in standard form. So it's equal to 0 or it's equal to y. One thing about the quadratic formula is it always works. You know how when we graphed, sometimes we didn't have any x-intercepts, the parabola never touched the x-axis? Well, we still have evidence of that. We can still make the quadratic formula. You know how sometimes we couldn't factor, they were prime? Well, we still have solutions. They're just irrational. Remember on the graphs how they were between two numbers? Now we know exactly where those are. So quadratic formula always works. And here it is. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Notice that whole thing is divided by 2a. And notice that there is a plus and minus in there because we have two possible answers. Just like when we completed the square, we took the square root, and I kept saying the square root of 16 is both positive 4 and negative 4. So we've got two possible answers. The a, b, and c come from the same place the other a, b's, and c's came from, which is from our standard form equation. The a is the number in front of the x squared, the b is the number in front of the x, and the c is the number floating by itself, also the y-intercept if we graph. So here's a good way for you to remember. Remind me to play this in class for you too.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Let's try that one more time. Oh, let's see. Let me move that back. Here we go. I'm not very good at YouTube. It's a catchy tune. It'll get stuck in your head.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
There, I'll play it for you in class again too, because I know that's a really catchy tune. So, all right, let's keep working. So really for this section, what we need to do is practice. So let's do this first example. It'll come out nice and neat. So my equation is x squared minus 2x minus 24. Notice it's equal to 0. So I can define my a, b, and c. What's my a value? Remember, no variables. Sometimes people try to put variables into the quadratic formula. That's a mess. We don't need variables. We only need the number in front of, or the coefficient. So negative 2 and negative 24. And let me get that quadratic formula in here. So x equals let's see, here we go. So let's put this stuff in here. Make that a little bigger so you can see it. So negative b, this is just like when we were graphed and we did negative b over 2a. If we've got b as a negative 2, and we're going to make it a negative, that means we're going to have a positive 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a times c. Well, a is 1 and c is negative 24. That's all over 2a. I like to fill everything in first, and now we're going to do the math. So here's how you should do the math to keep yourself from getting screwed up. First of all, I am sure that you have heard me say at least 100 times, when you square a negative, what is the sign? Do you see in this highlighted underneath the square root part why I asked that question? If you're not careful, you're going to goof up and get a -4 for that first part. So put that -2 in parentheses. You could type that straight across into your calculator, the part I highlighted. Do not put the square root sign. So when you do -2 squared minus 4 times 1 times -24, I got a 100 for underneath that square root sign. It's still +2 plus or minus, and that's all over 2 times 1 or 2. This is really nice, right? Because it's asking us to take the square root of 100. Is 100 a perfect square? Why, yes, it is. What's the square root of 100? Notice how when I take the square root of 100, I get a 10. There is no square root left. It's not a decimal. I get a nice, neat number. So now I've got two problems that I'm going to do. I'm going to break this up into 2 plus 10 over 2 and 2 minus 10 over 2. Just like with our completing the squares when we had a positive and negative answer. When you're doing your calculator, it's going to follow the order of operations. So do the numerator, hit an equal sign, and then divide by 2. So 2 plus 10 is 12, divided by 2, x is 6. 2 minus 10 is -8, divide that by 2, and x is -4. We have solved that. If we had graphed that equation, we would have had x-intercepts at 6 and -4. If we had completed the square, we would have solutions of 6 and -4. If we had factored that, we would have had solutions of 6 and -4. It works every time. Quadratic formula is a great fallback method because it always works. All you have to really do is get used to the formula, identifying your A, B, and C, making sure it's equal to 0, because that could really goof you up. Uh-oh. There we go. All right, let's try another one. Let's try this one. Example 2. I think we'll skip. We'll just do a couple here. Well, here's my equation. 15x squared minus 8x equals 4. Are we ready to identify our A, B, and C? What do you notice is wrong with this? It's not in standard form, right? It's got to be equal to either 0 or y. So how am I going to get this 4 to the other side? Oops, I forgot the x on my 8. That would be important because those are not like terms. So I've got to keep 3 things separate. I've got myself a trinomial equal to 0. So now my A value, B value, and C value. The signs are really important when you identify A, B, and C, so please keep close track of that. I wanted to do an example where our A value would be a number other than 1. These kinds of problems, we can't actually complete the square because we've got an A value other than 1. So completing the square wouldn't work here. Here's our quadratic formula. Plus or minus. Okay, so what is a -b? We've got this same case where b is already negative, and we're going to do a -b. So I'm going to end up with +8 plus or minus the square root of b squared minus 4ac. What's my a value? Well, 15 goes in there, c goes in there, all over 2a. So again, we're going to start by doing just under the radical. Make that a rule. Always do what's under the square root. Worry about the square root sign after. So this time, remember when you square -8, you get a +64 minus 4 times 15 times -4. When I did this math, I got 8 plus or minus. What you get underneath that square root sign? I got a 304. Tell me if I'm wrong on that one. And then notice that's all over 30 because I did the math 2 times 15. Is 304 a perfect square? No, it is not, right? We've got ourselves some kind of crazy decimal, irrational answer. This is where we'd have two irrational roots because if we graph these guys, we've got crazy numbers going on. So square root of 304, I'm going to stick to two numbers after the decimal like we did for completing the square. So I'm going to say that's 17.44. So I've got 17 point, is that right? 0.44? Yes, 435. So that means I'm going to do two problems. 8 plus 17.44, divide that by 30. 8 minus 17.44, divide that by 30. The only sign that changes comes from that plus or minus. So again, when you do your calculator, do 8 minus 17.44, hit an equal sign before you divide by 30. The reason is if you do just subtraction and division, your calculator is going to divide 17.44 by 30 before it does 8 minus. So we have to hit an equals at the end of each numerator. When I did my problems, I got an answer of negative 0.3. I didn't round right. I better double check my math here. So 8 minus 17.44 is a negative 9.44. Divide that by 30, negative 0.31. And 8 plus a 17.44. Check your math on this. Remember to hit equals. I got a 0.85 when I rounded. 0.85. So there are my two answers. They're not nice and neat. They're irrational, but they're still answers. Right? What do you think of this? Here's a little thing. We should add this somewhere. Add somewhere on the side, the margin, something. If you get a negative answer under the square root, try to take the square root of a negative number. Tell me what your calculator tells you. I bet you it's going to have some sort of error. Your answer will be no solution. You get a calculator error because we don't take square roots of negatives. So you would just write no solution for that. That means that the graph never would touch the x-axis. There's no x-intercepts. All right, so here's what I would like you to do. Your lesson summary is to fill this out. Find at least, fill out chart. Find at least one comment for each method. So you could kind of take out this when can it be used in comments. So something like a pro or and a con, something good about it, something bad about it. Come up with something for each one of these methods. So factoring is where we would multiply to a times c and add to b, or do the square method. Graphing, what's something good about graphing, something bad about graphing. Completing the square, one thing I would say is you can only do that when the a value is 1. Using square roots like 9,4b, where it's already a perfect square trinomial, so you can do the factoring shortcut. It's already got to be a perfect square trinomial, though. That's something I would mention. Otherwise, you can't do that so easily. And quadratic formula. One good thing about the quadratic formula I would write is it always works no matter what. So that is your lesson summary. Whoop, did I not put that in there? Oh, there it is. Fill out the method table above. Tell me at least one thing about each method to solve a quadratic. I said one pro, one con. If you have one thing for each, I'd be okay with that. I do have a practice problem. I want you to find the solutions for x squared plus 2x plus 7. That's ready to go to identify A, B, and C. And this is the end of section 9.5a.